Recording started. Recording started.
All right, back to
There's a thing called 2plus.com. I know where to get stuff. We're just trying to limit the number of arrests.
So one of the first thing on the recording, we're just trying to limit the number of arrests. Today's safe word is frappe. All right. What we talking? Oh, here's our grammar. If I remember correctly, we had a little bit of a chicken or the egg issue at the end of class last time. Yeah, chicken or the egg. Which came first, chicken or the egg?
Is that a thing?
Huh?
I've seen a comic that answers the question.
Is it like a funny answer or is it like a stupid answer?
We doubt now.
What's the comic?
I once went to a restaurant that attempted to answer the question.
No.
On their wall, the restaurant was called Les Peep. It was a little French restaurant. And it said, which comes first, lay chicken or lay egg? Les Peep. Get it? The restaurant came first. Ha! You're late. You missed a quiz.
I thought it was gonna be some crazy food where they had like hard-boiled eggs inside like chicken.
Yeah, like some massive like hard-boiled eggs inside of chicken instead of a yolk.
Like a chicken inside of it. They just had fertilized eggs that were fully grown and just the chicken that's inside the egg.
All right. So where was our confusion?
Tyler just said.
Yeah,
Or-
seriously. We're trying to think how we want to do it.
Oh, right. So shut up. All right. So for our for statement, we decided the first part of it is this thing of it called an assign expression, which we wrote the grammar for that last time, where it can either be nothing or it could be an identifier followed by an expression. For right now, we're not allowing multiple values to be defined. They're just a single value. The middle element is an expression, which can be a literal, an identifier, an expression followed by a mop expression, or an expression followed by a bop expression. Now, and then the last part we're saying is an assign expression. Now we know that for a for loop in real life, this guy's always a Boolean expression.
What's a for loop in real life?
Well, what we're used to. Not the for loop we're writing, the for loop we're trying to mimic. We know this guy's always a Boolean expression, correct? And this guy's always a what? An expression that either increments something or decrements something or changes a variable in some way. Do we have to change a variable in some way? I think we tested that last time, didn't we? Okay, so it's fine with us not doing it up there then. All right, so this can be null. This can be null. This can also be an assignment expression. Is this also an assign expression?
No.
This guy over here, where you're assigning a new value.
Oh yeah, yes.
So we wrote this assign expression thing where we said it's either null or it's the name of a variable followed by an expression. Okay? So we're not allowing you to define a type here, however. Where in a typical for loop, couldn't we have a type before our assign expression? In a real for loop, we could say int I is equal to 0. Or we're giving it a type as well. So does that mean that the version of an assign expression that has a type in front of it also needs to be here? Well, can that be over here? For loops are proving to be a bit tricky, aren't they? Go ahead.
I found out the really hard way that is before C99 C, you couldn't initialize it.
Mm-hmm.
I found out the really hard. There's blood everywhere.
By a hard way, you like tried to do it, and then compiled it, and it yelled at you?
That, and I just didn't even think to check that.
Oh, I see. You thought the error had to be something else. All right, so this guy right here can be nothing. It can be a assign operation, sign expression rather, a equals 7. It can be int a equals 7. Anything else can be in there? Can it be a literal? Nope. What else is there? Can it be an if?
Put another for in there.
For loop. What the heck?
So it seems like we're down to 3 things, right? Type followed by variable name followed by value. Variable name variable name followed by assignment operator followed by value. Here. Let's give a name to this. Type assign expr is a type followed by an identifier followed by equal sign followed by value. Yeah, type assign expression, so no semicolon.
Is it a value?
Oh, sorry. Then an assign expression can be null, it could be an identifier equal to that, or could it be a type define expression? Can we just put this in here? That's what we started out with, and we have the issue that if we intend to say this guy is the same as this guy, well, maybe I need to ask it this way. Can we possibly say that this guy and this guy are the same? Similarly, is it fine to say that this is just an expression, or does it need to be a Boolean expression? What is a Boolean expression? Is this a Boolean expression? Something that has a Boolean operator in it? But this thing says that this can be an expression followed by a Boolean expression. Well, an expression followed by 0 or more Boolean operators followed by expressions. Where the only version of an expression that this supports would be something on the left-hand side, if it was a Boolean expression, is something that boils down to true or false. How do we write that? How do we write the language of Boolean expressions? So a Boolean expression can be a true, it can be a false, or it can be a what? Can a Boolean expression boils down to a single value of true or false. So how else would we describe a Boolean expression? It could definitely be a true, it could definitely be a false. Those are our two literals. So rather than hard coding in literal, we specified which literals. Right? Do we need to have a language of our different literal types? For instance, do we need to do something like this? Do we need to define a language of Boolean literals, where this is true or false? Then do we have to have another language, numeric literals? This is 0, 1, 2, 3, 4, 5. Actually, we probably write it this way. 0 through 9. At least one time. So one or more times to create a numeric literal. What other kind of literals do we have? We have string literals. What's a string literal?
Numeric literal have like negative stuff and like decimal
Yep.
points in it too.
So a string literal is going to be an opening curly brace or opening double parenthesis. Why can't I say it right? Double quote. Man, I feel like Skippy today. So double quote followed by 0 or more Unicode. What's Unicode? Yeah. First we have to keep going. So yeah, I'll just say Unicode. It's fine for right now. 0 more Unicode followed by double quote. Numeric literals. How did we do optional last time? We did the little thing like that. I don't remember what our syntax was for optional. We can optionally have a minus sign. Right here. This will work. There, that handles positives and negatives. In regular expressions, plus typically means one or more. At least one of these, where asterisk usually means 0 or more. Okay, so Boolean literals look like that. Numeric literals look like that. String literals look like this. What other kind of literals do we have? Char literals? What's a char literal? Single quote, Unicode, single quote. Exactly one Unicode. And then what's Unicode? (65,535) unique characters. So we would have to innately support that in our language. Okay, so we've defined what Unicode is. Boolean literals are trues and falses. Numeric literals are positive and negative numbers containing at least one digit. String literals are anything that has a double quote followed by 0 or more. And I'm actually going to take the parentheses out of here. I think this is good enough. So double quote followed by 0 or more Unicode characters followed by a double quote. Char literals are single quote followed by exactly 1 Unicode character followed by single quote. Is there another form of the char literal? Go ahead. ANSI or ASCII? ASCII. What's the difference between Unicode and the ASCII character set? Unicode's a superset of it. So the first 256 characters of Unicode are ASCII. But what would be it? There's a special caveat in here. I don't know if we're going to implement most of this or some of this, but we'll at least cover it here. There's a special form of a char literal that we could use. What if I want to represent the char double quote? Yep, so we need single quote backslash Unicode. Like that. Okay. Now we're back to Boolean expressions. A Boolean expression is either a, well, we don't need these anymore. Now we could say this is a Boolean literal. A Boolean literal is a Boolean expression. Or what? What else makes Boolean expressions? Say this again. Okay, well, Boolean operator would be used to, so bops would be used to, we have them defined somewhere, don't we? Oh my gosh, we didn't define those yet? So bops, what's a bop? Less than or equal to, greater than or equal to, not equal to, and, or. We support anything else? Oh, not. Is that all of them that we supported? Or at least close enough for our example here. We can always come back and add something here. So that's a bop. So what's a Boolean expression? Boolean expression can either be a standalone Boolean literal. So true is a Boolean expression, false is a Boolean expression, right? Boolean expressions are any expressions that boil down to a single value of true or false. What's a more complex Boolean expression look like? Go ahead.
Expression, bop, expression.
Okay, expression, bop, expression. Well, let's go look at our expression. We can have a literal. It's okay. We can have an identifier. That's going to boil down to a value, which is essentially a literal. Or we can have an expression, mop expression. So like a math expression, or we can have an expression, bop expression, Boolean expression. Well, here's the question. Is it safe for me to say, as an example of this one, could I say 5 and 7? No. It's not a legal expression. So do I need to distinguish between bops? I need to have my Boolean arithmetic operators. BAOPs. And then I need to have my Boolean logical blops. And or not. Go ahead.
So like, why can't you do 5 and 7? That's true. Like in like a language like Java or in any C, 5 and 7.
Well, it's not gonna. It's undefined for argument types int and int. This operator has to have Booleans on either side of it. In an older language like C, you could probably get away with this because true and false are 0 and non-zero. So 5 would be considered to be a non-zero number. But you would have to be reliant on a language that still treats Booleans as integers distinctly, rather than being abstracted like Java does. So Java abstracts trues and falses from zeros and ones. All right, so we have our blops. We have our BAOPs. So Boolean expression can be a expression followed by a BAOP followed by an expression. Well, let's look at expressions again. It could be a literal. Well, it depends on which literal. Because we can't say things like true is less than false. So we can't even say expression here. What we're starting to see here is that grammars are by far harder to come up with than implementing them once we have them. This is the hard part of putting together a compiler, is getting the grammars right. So we're only going to take this so far. We're only going to keep piecemealing our language out to a certain extent. But if we're dealing with math stuff, what needs to be on either side of the BAOP is a number, correct? Our language supports integers right now. We're not supporting decimal point stuff. So we need to have a number on either side, something that boils down to a number. Chars would boil down to a number. Strings, we'd be comparing pointers. But we should be able to ask whether or not a char is less than or greater than another char. Strings, we probably shouldn't worry about pointers. So how do we define the grammar? How do we define the language that is the language of all numeric literals, char literals, things that boil down to numbers, and things that boil down to chars? Let's look at our expressions. Would this expression and our math expression, does this guy always expect numbers on either side? When we say something like an identifier, does that leave us as the language writer off the hook for worrying about whether or not it's the right kind of value or not? We have the opportunity to give them an error message during runtime, right? Or during compile time, in our case, since we're writing a compiler. So things that could be math expressions would be things that have numbers on either side or things that have identifiers on either side, where an identifier could boil down to a number. And until we've actually dereferenced it and gone and looked it up, resolved the variable, we can assume that it will be a number. That makes sense? Okay. So, is it safe to say a grammar of expression? Can we say it's an expression followed by a math operator followed by expression? Is it okay to be that generic? What can an expression be? Well, it could be a literal. What if I have a number literal here? Is that okay? Yeah, what if I have a string literal here? But when I say generic literal, is a string literal an expression? That is. Char literal, that's its expression. So all of our literals belong in our grammar of expressions, don't they? Which literals belong in this production of this grammar? What things can we do math operations on? Here's our mops. Where's our mops? Do we not write mops? We're going to write mops. Plus, minus, times, divide. Do we do modulus? Good enough? Okay, so these are our mops. So what things can be on either side of our mops? Can we have Boolean literals? No. Can we have numeric literals? Yes. String literals? No. We're going to pretend like concatenation doesn't exist in our language. Char literals? Yeah, we can add A to B. A plus B is 195, and if I want to get the char version of that, oh, that's just horrible. Is that a, what's well, the NEA is part of Spanish, but is there an A with the NEA on top of it in Spanish? I don't think so. I think this is made-up letter?
That's the best made-up letter.
Okay. More than likely, it was a character that couldn't be displayed by the terminal in Eclipse.
Character is too perfect for our eyes.
That's right. Okay. So, can we have something called a math expression? So we can have a math expression. A math expression is a identifier followed by a mop followed by a identifier. Is that an example of a math expression? And can we have 0 or more of these? In this case, we assume that this identifier will hold something that's mathable. A number, right? So we can write syntax that is illegal syntax, but technically matches the idea of a math expression. But when we look ahead and we say, oh, okay, well, this guy needs to be a number, we can take him as an identifier initially. Correct? Okay. What else can this guy be? Go ahead.
You want to change the second identifier to a math expression?
We can do that. Okay. Well, having said that, can the first one be a math expression? Is a identifier a math expression?
Not necessarily.
But could it be? If I have a variable named A and it happens to hold the value 5, is just saying A a math expression? It is. Is a, what do I call it, number literal? Numeric literal? Is that a math expression? Char literal? Is that a math expression? Just for sanity's sake, we'd probably move this down to the bottom. Go ahead.
You're doing like pointer math stuff. Is that a math thing?
I would say let's not worry about pointer stuff.
Well, is it like another expression then? My own notification? Or?
Okay, you're asking if we have a pointer and we add to it another pointer?
Yeah, or if you're just like trying to walk through an array or something and see stuff like that.
No, it's regular math. Because you're just doing hexadecimal numbers. I mean, it's just indexes. You just happen to be representing it in base 16 rather than an integer or a decimal integer. All right, so math expression could be an identifier. It can be a numeric literal. It could be a char literal. It could be any one of those things by themselves. Or it could be a math expression followed by a mop followed by a math expression. 0 or more. But actually, if we write it this way, wouldn't we say this is 1 or more? Because if it was 0 or more, isn't math expression redundant for what we already have up here? So this says anything that fits any of these guys followed by at least one of these guys over here. All right, so that's our math expression. Now we're back to our Boolean expression. Boolean expression can have a Boolean literal. It can have an identifier. Or it can have a Boolean expression followed by a BAYOP followed by a Boolean expression. At least one of these. Or it can have a how do we handle the blops? Versus BAYOPs. These guys need numbers on either side, correct? So really what we have written so far, this guy needs to be a blop. This is a Boolean logical expression. It could be a Boolean literal, an identifier, or a Boolean expression, Boolean logical expression, followed by a blop, followed by a Boolean logical expression. Boolean arithmetic expression. This can be an identifier. It could be a numeric literal. It can be a char literal. Any other kind of literal? Or this can be a Boolean arithmetic expression followed by a BEOP followed by a Boolean arithmetic expression one or more times. So then a Boolean expression is a Boolean logical expression or a Boolean arithmetic expression. Make sense? Okay, so this is all abstraction. What we're doing here is basically kind of like inheritance. So we have two different broad classifications, well, two different detailed classifications of Boolean expressions, logical expressions and arithmetic expressions. Then we have a broader class of Boolean expression which covers either one of those. So now in our for loop, can't we now say this guy is a Boolean expression, that centerpiece? Okay, but now we need to go back to this idea of an assign expression. We have I'm going to rename this guy type def expression. So it's going to be a type followed by an assign expression. Do I have my assign expression anywhere? Did I already? There it is. Let's see. A type def expression cannot be null. So for instance, I couldn't just say so type identifier equals expression. That's our type def expression. Assign expression can be null. It can be an identifier is equal to an expression. Is that it? Two different types of expressions. We have one where we define the type followed by identifier followed by expression, and it requires all those pieces. We also have, actually, does it require all those pieces? Can I say, says it just may not have been initialized. But I could say it j is equal to 5 and do this on j. And it's fine with that. So another type expression would be type followed by identifier. Like that. Have we listed somewhere what all of our types are? Let's do it right here. So what are our types? Type expression. Well, we have int, char, Boolean. Good enough for our starting little language. Okay, so that's a type expression, which means that a type def expression is going to be a type expression followed by identifier followed by an expression, or a type expression followed by identifier. Make sense? Grammar of expressions. Does this guy change now that we've defined all these other things? An expression can be any literal. It can be any identifier. Math expression, which we defined here. And Boolean expression, which we defined here. Make sense? All right. Okay, so we have all of our literal types. Then we have a BAOP, a BLOP. We have a Boolean logical expression, which is written in terms of blops.
I have a question.
Go ahead.
We also have in here Boolean expression, block Boolean expression. Or instead of the logical expression, because you could also have a Boolean arithmetic expression.
Yeah, I agree. So you just want to replace this. Yeah, because really a Boolean logical expression can be anything that boils down to a value of true or false, followed by a BLOP, followed by anything that boils down to a value of true or false. We just need to make sure that there's trues and falses on either side. Arithmetic, identifier, numeric literal, char literal, same thing here. Just a Boolean expression.
No.
I think so. No, it needs to be a arithmetic. Oh, which actually breaks the other thing. No, it doesn't. We're good. A BLOP requires this to be anything that boils down to true or false on either side. A Boolean arithmetic expression requires, so a BAOP requires this to be anything that's mathable on either side. So calling it a generic Boolean expression would not suffice. We're going to get trues and falses out of that we're going to try to say is true less than false, and that's not going to work. Then we have our more generic Boolean expression, which is anything that boils down to a single value of true or false, which can come from a Boolean logical expression or a Boolean arithmetic expression. Then we have our MOPs, math operators. Then we have our math expressions, things involving our math operators. Then we have our grammar of expressions, which is a literal identifier, a math expression, or a Boolean expression. Then we have a type expression. So does type expression fall into grammar of expressions? type expression, we have type def expression. And so right now, does it seem like we need them? Say no. Okay, so now we have type expressions. This is our types. Type def expression, this is a type expression followed by an identifier, followed by an assignment operator, followed by an expression. Or we have a type expression followed by just an identifier. Assign expression can be null, or it can be an identifier followed by an expression. Grammar of statements. For what's this first part of a for loop going to be? We want it to probably be an assign expression, but we want an assign expression to either be a null, an identifier followed by an expression, or a type def expression. This guy?
Except that the second one there isn't an assignment expression.
That's true. But it technically is allowed in a for loop. Maybe we just change the name of this. Instead of it being an assign expression, it's... Is there something wrong with having specialty expressions specifically to make for loops work? Could we call this a for part one expression? It's not unfair to say that, right? So for part one expression can be nothing. It can be an identifier followed by an equal sign followed by an expression. It can be a type def expression. Or it can be, well, a type def expression would be any of these. So does it cover that? Would we ever use these on their own anyplace else? So realistically, couldn't we just add them in here? And get rid of type def expression? Could we just say for part one expression could be any of this crap? So then we get to our, this is for part one expression. That's the type of dude that lives there, right? Followed by a Boolean expression. Okay, so at the beginning of next class, we'll pick up and we'll fill in the gap for this very last part, which interestingly enough is exactly where we left off last class. But imagine how much we've accomplished. All right, I'll see everybody on Wednesday.